Hello, everybody. Welcome to one more exciting session in the series AWS Bootcamp. In this session, we'll try and understand what is load balancing means, and we will understand what is the service that AWS offers to use load balancer, that is Elastic Load Balancer, and we'll understand the different types of load balancers that AWS provides. That is what we would cover in this particular session. First of all, let us try and understand load balancing. What is a load balancer or why we should balance the load? Now, load balancer is nothing but you can say that it is a server. And what is the job of that server? That forwards traffic to multiple servers. An example of that server that forwards traffic is nothing but a EC2 instance. Okay. So now a load balancer, it can take the request from the users and transfers the traffic to the multiple servers. That is the job of a load balancer, to balance the load between the servers. And now there are some of the uses of load balancer. One is that because it manages multiple servers, if there is any hardware failures in the downstream instances, it makes sure that the request is not forwarded to that particular instance where there's a failure in the server. And it does the regular health checks to make sure that all the instances are up and running, and it makes sure that the servers are there in high availability across the zones. Okay, now it spreads load across multiple downstream instances. You can have around two instances, three instances, four instances. Load balancer will ensure that all the servers are getting even load, and it exposes a single point of access DNS for your application. It provides SSL termination for users' website and separates public traffic from private traffic. These are some of the uses of load balancer. Now, if I have to configure this load balancer, what I have to do, first of all, I have to purchase a virtual instance or a virtual machine, or in short, we can say EC2 instance from AWS, and then configure that server as a load balancer. But AWS offers a service called as Elastic Load Balancer. Now here, what AWS does is that AWS will take care of all the infrastructure. This is a managed service from AWS. So what is an Elastic Load Balancer? An Elastic Load Balancer is a managed load balancer. That means all the infrastructure is taken care by AWS. We can straight away start using the load balancer features. Now, AWS will take care of upgrades, maintenance, and the high availability. Now, AWS provides only a few configuration knobs. It is integrated with many services. Now, Elastic Load Balancer on AWS has integrated with services like EC2, EC2 Autoscaling, ECS, CloudWatch, Route 53. It is integrated with a lot of services, so it is very easy to use. Okay, and it costs less to set up your own load balancer. So rather than configuring your own load balancer, using Elastic Load Balancer is very less expensive. Now there are different types of load balancers that AWS offers. One is called as classic load balancer. Second one is called as application load balancer. Third one is called as network load balancer and gateway load balancer. These four are different balances the load in different ways. We will see each one of them, in which scenario we need to use which kind of load balancer. Now first let us start with classic load balancer. The classic load balancer, which distributes the incoming traffic across multiple instances in multiple availability zones, is called as classic load balancer. So basically it does the work of a normal load balancer. uh, it distributes the traffics to multiple EC2 instance. It supports TCP, HTTP, HTTPS, and SSL listeners. It will do the health check of TCP or HTTP based, increases availability of users application by sending traffic to healthy instances. It has fixed host names. Like if you create a load balancer, the host name would be whatever the name of the load balancer that you give, followed by the region, followed by ELB Amazon aws.com. This would be the DNS name of this particular uh, load balancer. So now let us see, visualize this in form of picture. Now let us say there's a client. Now we are getting a request from the client. Now what we're using here, we're using something called as classic load balancer. Now once the request comes here, the request is sent to this EC2 instance. Now let us assume there is one more EC2 instance and one more EC2 instance that is attached to this particular load balancer. Now what happens? As soon as the user, if uh, there's a one request is coming, this request, let's say, is sent to this EC2 instance. Okay. Now let us say there is another request that coming, and this request is sent to this EC2 instance. Let us say there's one more request from the user, and now this request is sent to the third server. So it follows different types of algorithm to which instance the load has to be, the IO request has to be sent. So that is how the load balancer distributes the load to different EC2 instances that are attached to that particular load balancer. Okay. And now let's say load one more function of load balancer is, let's say, let's say now we have this server, right? This is an EC2 instance. Now if this is unhealthy, if the server is unhealthy, if we send a request to that server, it will not be able to process the request because this server is unhealthy. And load balancer will keep a track of all the unhealthy servers, and it will not send the request to the unhealthy server. In this case, if this is unhealthy, load balancer will only send the load to this server and this server. Okay, in that way it also makes sure that all the it will keep a track of unhealthy servers as well. And it works on which protocols? It works on TCP, HTTP and HTTPS protocols. Okay, that is about classic load balancer. Now we don't use classic load balancer much, because there are a couple of limitations. Now for each load balancer per region you can create up to 20, you can create up to 50 listeners, 5 security groups, you can register up to 1000 instances in one load balancer, and subnets per availability zone 1. These are the some of the limitations for the classic load balancer. Now the widely used load balancer nowadays is called as application load balancer. Now let's see what is this application load balancer. The load balancer which distributes the traffic to appropriate target groups on the basis of the content is called as application load balancer. So now what does that mean? Now let us say, let's take an example of an application. Okay, this application has two tiers. Now let us say one tier is called as orders, second tier is called as payments. Okay, now any request coming to orders, I want that to send to a set of servers. Any request coming to payments, I want them to send to a set of servers. Then what I can do, I can group, let's say this is my 4 servers where my application is spread across. Now let's say I'm reserving these 2 servers only to process the request from for orders, and these 2 servers only to process the request related to payments. Now, what an application load balancer will do, with the help of application load balancer, we can transfer the traffic, or we can uh, redirect the traffic based on what kind of content, what kind of request that is coming. Okay, that is the application load balancer. Now, to create that, first of all, we have to create something called as a target group. Okay, we'll discuss more about that once you do hands on. We have to create a target group, and let's say these two are target group. I'm uh, redirecting all the traffic related to payments here, and this is another target group. I'm sending all the orders related traffic to this particular target. Okay, now the load balancer which distributes the traffic, appropriate target groups on the basis of content is called as application load balancer. Now, load balancer to multiple HTTP applications across missions. Okay, it reduces hourly cost. It supports microservices and container based application like for example Amazon EC2 and Docker. Okay, if your application is a microservices based application, the best approach is to go for application load balancer, and it supports WebSocket like HTTP and HTTPS. That is what is a application load balancer. We will do a hands-on exercise on that, then it will be more clear for us. Now, some of the benefits of application load balancer is it supports host based routing, and health check monitoring is there anyways even in classic load balancer. Here also the load balancer will do the health check of every server. It supports path based routing. So when we create some rules, we will see this path based routing, then we'll understand what is the meaning of path based routing. So based on the path, the routing will happen, and it is better for performance. It route requests to multiple application host on a single EC2 instance. So now on one EC2 instance, let's say there are two services or two applications. So then I can redirect the traffic to applications. Okay, and it supports registering of target IP can be outside VPC. These are the some of the benefits of application load balancer. Now, if you look at this picture, you can understand that there are different types of requests coming for the application, and this is an external application. Okay, now let's say a couple of requests are for the user and couple of requests are for the search. Now what we have done, we have created two target groups. One target group is called as user, second target group is called as search. Now whatever request that is coming for the user, it is going to this target group which is user, and there are two instances in that. And whatever request that is coming for the search application, it is going to the target group search, and there are EC2 instance in the search. So we will establish this hands-on lab. So we will create multiple servers and add them to the target groups, and we'll create these small applications user and search, and then we'll redirect this user request to this users group and search request to this search group. All right. Now let us look into one more simple example of application load balancer and how the target groups work. Now if you see, we are getting multiple requests from the external load balancer for the two applications. One application is called as mobile application, another application is called as desktop application. But in this scenario, our mobile application servers are hosted on AWS, and our desktop application is hosted on on-premises servers. But still our application load balancer can work. So we can create target group 1 and add the servers which are on AWS, and we can create target group 2 and add the servers which is there uh, on premises. We can also create a application load balancer in this way as well. And a couple of good things to know about application load balancer. And the DNS name for the application load balancer would be fixed, and it would start with the name of the application load balancer with the region, followed by the ELB Amazon AWS.com. And the application servers do not use the IP for the client directly. The true IP of the client is inserted in the header X forwarded for users. Can also get the prototype. Okay, now this is how the application will work. Now let's say the client IP address will communicate it with the application load balancer, and the application load balancer will communicate with the EC2 instance. That is how the communication will happen. All right, now let us look into the next type of. Let's see the limitations of application load balancer, and you can create around 20 load application load balancer per region, and the target groups is about 3000, and the load balancer components, like you can add up to 50 listeners targets, you can add up to 1000 EC2 instance, one subnet, 5 security groups that you can add, and you can add up to around 100 rules. What are rules? You'll see once we create an application load balancer. and you can also add certificates, and number of times a target can be registered is about 100. These are the some of the limitations of application load balancer. And now let's look into network load balancer. Now, if application load balancer is balancing the load between two applications, okay, or you can say between two microservices in an application, then what does a network load balancer will do? A network load balancer makes routing decisions at a transport layer. Okay, network load balancer layer 4 allows in the OSI layers. Network load balancer basically works at a layer 4. It forwards TCP and UDP traffic to user instances. It can handle millions of requests per second, and the latency is very less. That means the performance is extremely good in case of network load balancer. So if you're working with something like IoT devices, or if you're working with some streaming data, or if you're having millions of requests that are coming in, it is better that use a network load balancer. After the network load balancer receives a connection, it selects a target from the target group for the default rule using a flow hash routing algorithm. Once the network load balancer receives some request, it will select the target to which it has to send the data by a hash routing algorithm. Network load balancer basically attempts to open a TCP connection to the selected target on the port specified in the listener configuration. So basically we have to create something called as listener configuration. Based on that, it will select a port. It forwards the request without modifying any headers. Network load balancer supports dynamic host port mapping. This dynamic mapping allows you to have multiple tasks from a single service on the same container instance. That is what is a network load balancer is. Now, if you look at that, the same thing what we have looked into previously, where there are two groups, users plus search. Now here, the network load balancer works with TCP rules, okay, and then it will try to open a TCP or UDP port, and then it transfers the request to a required target. Okay, now network load balancers, and obviously there are target groups in the network load balancer also. And now a network load balancer can have two. If you see in the first picture, it can have two servers, okay, as targets, and you can have one server from the EC2 that is on AWS, and another target from on premises, or you can create a target group. That means your application load balancer can be a target. These are the three ways how you can configure targets in your network load balancer. It can be two EC2 instances, or it can be a network load balancer, or it can be an application load balancer. Those can be the targets in a network load balancer. Some of the limitations of network load balancer: we can configure around 20 network load balancer per region. You can configure around 3000 target groups, listeners around 50, and you can target per availability zone with cross zone load disabled around 200, and targets with cross zone load balancing enabled around 200, and subnets per availability zone is 1. Those are the some of the limitations of network load balancer. Now the next type of load balancer is called as gateway load balancer. So till now we have discussed about classic load balancer, application load balancer, which is very widely used, and network load balancer. And the fourth type of load balancer is called as a gateway load balancer. So in a gateway load balancer, it allows you to deploy and scale, manage virtual appliances such as firewalls, intrusion detection and prevention system, etc. It combines a transparent network gateway, that is a single entry and exit point for all the traffic, and distributes traffic while scaling your virtual appliances with demand. In network load balancer operates at the third layer of open systems, that is OSA layer, which is third layer. Network layer is operates at the fourth layer, right? And it maintains a stickiness of flow of a specific target appliance using TCP and UDP flows. That is the use of gateway load balancer. You can deploy the gateway load balancer in same VPC as your virtual appliance, and you can register the virtual appliance with a target for the gateway load balancer. Gateway load balancers use gateway load balancer endpoints to securely exchange traffic across VPC boundaries. Now, if you look into this picture, you can easily understand that uh, all the traffic has to be routed through only one single gate point, which is called as gateway load balancer. Okay, there are route tables. All the traffic comes to the gateway, and the gateway decides, securely transfers the data to the application or to a target groups. That is what a gateway load balancer is all about. And in a gateway load balancer, your target groups can be EC2 instances, or your target groups can have EC2 instance as well as on-premises server as well. Okay, so in this lecture we have discussed about load balancer, what is a load balancer, what is an elastic load balancer, and we discussed about classic load balancer, application load balancer, network load balancer, and gateway load balancer. Now we will go and do a hands-on exercise of this particular load balancer. Let's start with an application load balancer. Right, let me switch to my AWS console to do this hands-on. Before I start the hands-on exercise, first of all, let me explain you guys what is that we are going to create. Okay. Now I'm going to create two EC2 instances. Okay. And this EC2 instance, let's say there's an application called as search, and this EC2 instance, there's an application called as users. Okay. Now we are going to create these two in two target groups. This is target group by name TG1, and this will be another target group by name TG2. Okay, and we are going to create an application load balancer. Okay, and connect these two target groups to the application load balancer. Now, if a user is requesting for the service search, if a user is requesting for the service search, the request has to go to this target. If a user requesting for the service users, this request has to go to this particular EC2 instance. Okay, in the target group 2. That is what we are going to establish. And to establish this, there are a couple of steps that we need to do. First thing, we need to create two EC2 instances, and we have to create a target groups application load balancer, and we need to deploy the apps by name users and search in the each EC2 instance, and we create an application load balancer and create target groups and add the targets and modify the listener rules in the application load balancer. These are the different steps that we need to do to perform this lab. Let me switch to my AWS console and then perform this for you. All right, this is my AWS console, guys. Let me go into the instances. First thing is that we have to create two instances. Select option launch instance, and I will name the instance name as for the application search. Okay, and I'll put that on Ubuntu OS, and I will create a key pair, create a new key pair for the application load balancer. Okay, it should be PPK because it is Unix based OS. Create a key pair. Okay, and I want to allow HTTP and HTTPS ports because this is a we need to convert that into web server to deploy the application, and create a instance. Now the instance is launched successfully. It is in pending state. It is still pending. Let us wait for one more moment. Yeah, you see that the instance is running now, and the public IP address of this instance is this. Let me connect to that, and let me log into that server. The username is Ubuntu. Okay, go to authentication, browse for the PPK file. This is the PPK file, open and open. Okay, I am able to log into this server now because I already gave a username. Let me log in as sudo user. Okay, now let me update the Ubuntu OS. For that, the syntax is sudo apt update, and then install Nginx. Sorry, install Apache. Okay, Apache is getting installed. Okay, now let's see whether this server has become as a web server or not. I'm putting the IP address in the browser and I can see the default page coming up. Okay, now I want to put the app search on this, right? Now, basically the default page will be there in a folder called as HTML. Let us see that cd var ls. Okay, if you see there's a folder called as www here. Okay, let me log into that. Let me enter into that cd www. Okay, now if you see there's a HTML file. If I go into that HTML file, HTML folder, okay, ls, there is a index.html which is a default. Now let me create one more directory here. Make directory search. Okay, now here I want to create an index.html. Let's say cat index.html. This this is for application search. Enter, Control D, that will save. Now let us see, go to this default page because we have created another folder called as search. Go to search here and then you will be able to see this page, index for search. All right. Okay. Now we see this application is good enough. Now let me do the same thing for the application users. Let us create a new server and do the same thing over. Okay, let me go to EC2 instances, launch instance. Application name is user, same Ubuntu. I'll use the same key pair, which is app LLB. And yeah, let us go ahead and launch instance. Okay, the system is in pending state. Let us wait for a moment. It's still in pending state. Let us wait for one more moment. All right, the system is up and running. Let me log into the server. Let me go to putty, new session, SSH, authentication, browse, open, accept. Default username is Ubuntu, and I'm able to log into this. update the server, right? Once it is done, let us install Apache. Now let's download Apache, sudo apt install Apache 2. So we basically install Apache to make this server into a web server. All right, now this server must be a web server now. Let's take a confirmation. Let's put that on the browser and check. Yes, it is by default. I can see that. Now let's go to that path. The path is cd slash var slash www slash html. You do ls, you can see that index.html file. Now let me create one more folder here. Make directory user. Now let me enter into that user folder. Okay. I'm logging as root user. Now make directory. Okay. Now let me go into that path cd user. Let me create an index file here. Cat index.html. Let's say h1. This app is for user. Okay, and control D. Now let me check whether it's working or not. This is the default page. Let me put a slash user there. Okay, this app is user, and this is the default page. If I go to search, I should be able to see this application is for search. Now I have both the servers ready. Now if a request is coming for search, it has to go to this path. If a request is coming for user, it has to go to this path. Let us go ahead and create a load balancer now. You see, this is the load balancer. So if you go EC2 instances, if you scroll down under load balancing, if you click here, you can see this page. Now select option create a load balancer, and we are going to create a network load balancer. We understood what is a network load balancer, right? Select this network load balancer, create, and give a name. Let's say demo LB. This is the name of the load balancer. And it is asking whether your load balancer is an internet facing or internal. My load balancer is an internet facing load balancer. Choose that. And the IP address is IPv4. I am choosing default networks, and it should be there in which region. Okay, now AWS have assigned you some regions. If you want them to be in two regions, you can select two regions. If you want this to be in three availability zones, you can select the availability zones. So I have selected the availability zones, and you can give up to five security groups. The rules up to five security groups. That is the max one of the limitation. So I choose a couple of security groups. And the listener should always be port 80. Okay, if it is HTTP traffic. And now create a target group. I don't have any target group, right? So if a request is coming, where it has to go? It has to go to the server, right? And the server should be there in a target group. First of all, let me create one target group. Select option create target group. Now this target group should have what? instances or IP addresses or a lambda function or an application load balancer. I want the instances to be there in this target group. I'm naming the target group name as search. Okay. And it is the protocol version is HTTP 1. And the health check should happen with the protocol HTTP. And it is there where it is there in a folder called as search. It has to the request has to be redirected to the server, and in the server there's a folder called as search, right? There it has to go. Okay, click on next. What is the server I have to add? This is the search server, right? This is where it is. And select option include as pending below and create a target group. So basically that means in this target group now, this server is there. Now we want another target group also, right? Let me create another target group also. There also instances will be only there. Okay, everything will remain the same, but the folder here is user. It is there in a different server, user. Okay, and next, what is the server which should be there here? Target group name is user. Click on next. Okay, this is the server name, user, and then select option include as pending below and create target group. So we have created two servers, and each server we have put in one target. So in one server, in one target group, we can put any number of servers. 1,000 is the upper limit. Okay. So, but as of now, in each target group, I'm only going to put only one server. Okay. Now, let me go back to this load balancer. Okay. Let me refresh this and see. I can see the target groups, right? Let me select option search. Okay. Search is the first target group. I have selected the target group and then create load balancer. Rest all will leave it for defaults. I'm selecting the option called as load balancer and choose view load balancer. It is in provisioning state. It would take a minute for the load balancer to become active. Now we can see the status as active. Now let us see once the load balancer is created. If you look here, there are a couple of tabs here. Basically description, all the metadata about this particular load balancer that we have created. It is there. What is the name of the load balancer? What is the ARN? What is the DNS name? So this is what we wanted. And whether it is active or not, whether it is internet facing or internal, if you want to edit the IP address, in what availability zone, all the configuration that we have selected. Now let me copy this, and if you want to see the listeners, it is there in this. We'll come to the tab in a bit. And the monitoring, if you want to see how this, how many requests are coming for the load balancer and all, you can see that in the monitoring. Okay, now the most important thing for us is the DNS name. Let me copy this DNS name because we have added one server there, right? Let me go here, put this and enter. You see, this is an application for search. Now type in here, search. Okay. You see, this is an application for search. That means whenever I have given the search here, it is going to this search EC2. Now on the ELB, if I give users, it should come to this EC2. Okay. Let me do that. For that, we need to edit the rules because till now we have just added one rule to that saying that if there's a request coming in, just send it to that particular server. Okay, now you see here in the listeners, we need to add multiple listeners here because we want the traffic to be routed. Go to option view and edit rules. Okay, go to plus inside a rule. I'm saying if the path is coming like search, okay, add action, forward that tag to search target group. Insert one more rule. Okay, this rule is fine. Let me copy this, save this rule now. Okay, let me add one more rule. If a request is coming for the path slash, I think it is the user, right? Okay, slash user. Asterisk means anything after user. Okay. What action it has to do? It has to forward that to the target group user. Okay. That is one more rule that we have added. Now let's say let me take this slash, let's put it user. Now the request ideally has to go to the user. You see this? This app is for user. Now if I put here search, it will go to the search. So that means the load balancer, it is redirecting the traffic based on the rules that we have configured. So I have told if the request is coming for the path search, go to the server. If the request is coming for the path users, go to the server. That is how the load balancer is balancing the load between the two servers. I hope you guys have understood this. In the next lecture, we will create a lab exercise for the network load balancer and gateway load balancer. I suggest you guys to do the hands-on exercise with the document that is provided for you guys. So you'll be more confident in understanding the application load balancer. Thank you very much. You guys have a good time.